Hello N3 students, today we're going to be doing RLC circuits, guys. Know that RLC circuits is an alternating circuit, and here is a simple circuit diagram which includes of resistor, inductor and a capacitor, guys. And since it's in series, know that the current is equal throughout, so the focus will be on the voltage, and each component has its own voltage, guys. So we're going to be starting with the series one. Know that the current is equal throughout, so the focus will be on the voltage, and the bigger value will decide the direction, guys. The bigger value meaning the bigger reactance, guys. Okay, we said the bigger value gives the direction, guys. So here the direction is up because the inductance is bigger than the capacitance, and we also have the impedance and an angle. Know that we use Pythagoras theorem to solve this whole thing. So we have the total impedance, which will be horizontal and vertical squared, because we use Pythagoras, and tan theta we know it's opposite over adjacent. So here the opposite of the angle is XL over XC, and the adjacent, you see, is the resistor. Okay, guys, and we said the bigger components gives you the direction. So here the direction goes downwards, meaning the capacitance is bigger than the inductor, so it will go down. And we still use Pythagoras, horizontal and capacitance squared, and tan theta now is still opposite over adjacent, guys. Still the same thing, it's just that the change of direction, because now the capacitor is bigger than the inductor. And if sometimes the components become equal, that means there will be no direction. And here are the calculations. A capacitor of 10F is connected in series with a coil of inductance of 10 mH and a resistance of 500 ohms to a supply of 20 V at a frequency of 12 kHz. Calculate the inductive reactance. So first, guys, I already wrote down the given, in which capacitor is 10 NF, and N stands for 10 to the power of negative 6, M stands for 10 to the negative 3, and resistance 500, and K stands for 10 to positive power of 3. So now we calculate the inductive reactance, guys, and this is the formula which will be given in the exams. You just have to know how to apply the formula. So let's calculate the inductance reactance, guys. So we say XL, which will be equal to 2 times pi times frequency F, in which they gave us a frequency which they said is 12 times 10 to the power of 3. Remember 12K, K stands for 10 to the power of positive 3, right? And the inductor, they said it was 10 mH, in which M stands for 10 times 10, M stands for 10 to the power of negative 3. Know that, guys. And now let's look for the and we found the answer to be 753,982 ohms. The reactance is measured in ohms, guys. And question number 2, they want us to calculate the capacitive reactance, in which the formula is also given on the exam. You just know how to apply it. So let's calculate, guys, which will be 1 over 2 times pi, right, times frequency, in which they gave us 12K, which is 12 times 10 to the positive 3, and the capacitance of 10 N Remember, n stands for 10 to the power of negative 6, guys. So it's going to be 10 times 10 to the power of negative 6. 10, sorry. Guys, remember 1 is on top, it's over. So actually, let me just try to make 1 is over everything. 1 is over everything, remember. So what is the calculation? What is the calculation? Oh, guys, sorry, I made a mistake, guys. N, that N stands for 10 to the negative 9, not 6. It's U, which stands for 6. So guys, please fix it there and make it to the negative 9. So in which I found my answer to be 1326,29 ohm. Remember, it's a reactance, so it's measured in ohm. And now we move on to calculate the impedance. Okay, the formula will be given. You just have to know how to apply it. You know that it's always big minus small squared. So you choose between the reactance, which one is big. So XL is big, so which means we'll minus XL from XC, you see. 1 minus XL 7, 5, 3, 9, 8, 2 squared. Know that squared, and which we are given R squared, which is 500. 500 squared. 500 squared plus squared. I forgot to add squared, guys. There. Please add it. Making mistakes. Yeah. So calculate everything. Please add squared there. I see. Yeah, but so I found the answer to be 760,418 ohm. So D, now we calculate for the supply current. Calculate. The formula will be given on an exam. Just know how to apply it. Total voltage is current over the impedance, in which we already just calculated the impedance. So we're looking for the total current. What is the total voltage? The total voltage, they said it was 20 V. So let's add 20 V there. 20 times current, we don't know, we're looking for it. We just calculated the impedance, which is 760,418 ohm. Right? Let's substitute now. I will be 20 over everything. 760,418. Right? Calculators, guys. Calculators, in which I found my answer to be 0,026 A. Know that A, in which I times it by 1000 because we want it to be in MA. Remember, M is 10 to the power of 3, right? Stands for 10 to the power of 3. And now we calculate the phase angle. The phase angle, in which we can calculate it in either using tan theta or cos theta. So tan theta, x, the bigger one, minus the smaller one. Look that. Comma 29 minus the smaller, which is 753,92,982 over 500. Let's substitute the theta. 1,144. Now they want us to draw the phasor diagram, guys. Remember, it's in series and we choose a side on which one is bigger. So which one is bigger, inductor or capacitance? Here is the inductor and down there is the capacitance XC. And we found out that which one is bigger, XC is bigger, so it will react downward, go downward. The total voltage will go downward, theta, and this is how it will look. This is how it will look, guys. Resistor and there its impedance. This is how it will look, guys. Thank you so much. And for that angle, please calculate it yourself.